design of cross section. You know that continuity equation. Continuity equation, I hope all of you know that Q is equal to A into V. This is actually continuity equation. Your Q stands for discharge and A stands for area and V stands for speed. Okay, here if I want to calculate A, I can rewrite this equation as A is equal to Q divided by V. Here Q stands for discharge and V stands for speed that is available in our problem, correct? No, discharge 0.9 is saying and speed 1.2 is saying. So if you use this, you are going to get area of the trapezoidal section required is how much? 0.75 meter square. Okay, now general trapezoidal section if you take and if you apply the general formula, area of the trapezoidal section general formula is like this. Area is equal to top width plus bottom width divided by 2 multiplied by height of the trapezoidal section. Here you can see top width plus bottom width divided by 2 multiplied by height of the trapezoidal section. This you can also write it as A plus B into H by 2. In our problem, this A value is how much? We already solved in the previous slide. You can see top width is 1 plus 3D, bottom width is 1. Therefore, here you can substitute it as A is equal to how much? A is equal to 1 plus 3D. B is given by 1 meter. B is 1 meter. By applying this formula, how it will come now? 1 plus 3D top width plus bottom width will be 1 multiplied by H. Depth we are going to indicate in terms of D. Therefore, this will be D divided by 2. Therefore, what is the expression now for this A now as per the general formula? 2 plus 3D 2 plus 3D to D divided by 2. Correct, no? I hope all of you are following what I am saying. Okay, this is 2, 1 plus 1, 2 plus 3D multiplied by this H divided by 2. I'm going to consider in terms of D divided by 2. You call this as equation number 1, that is obtained from the continuity equation. You call this as equation number 2. You call this as equation number 2. Now my question is, here also you find out the area and here also you find out the area only. Now what I'm going to, since both the expression indicating area of the trapezoidal section itself, I'm going to equate equation number 1 and equation number 2. Let us see how it will come. The same thing what I said here, I written here, equating 1 and 2. So what you are going to get? Equation 1 area is how much? 0.75. Equation 2 we got the expression 2 plus 3D into D divided by 2. Okay, so I will just cross multiply and do the things. Finally, I will get the expression as 3D square by 2 plus D minus 0.75 is equal to 0. You just rearrange these terms, cross multiply, take this D by 2 inside. So finally, I'm going to get the expression as 3D square divided by 2 plus D minus 0.75 is equal to 0. In this expression, only D is the unknown, correct? No? In order to find out D, I'm using this quadratic equation formula. Okay, in order to find out this D, I'm going to use this quadratic equation formula. X square plus bx plus c is equal to 0. You can see the same expression. 3 by 2 d square plus d minus 0.75 minus 0.75 is equal to 0. You can use this expression. In this expression, here you can take b as how much? B is equal to 1. You can take. Then you can take a is equal to 3 by 2. And you can take c is equal to 0.75. Okay, b is equal to 1, a is equal to 3 by 2, c is equal to 0.75. Substitute all here. You are going to get d as how much? 0.448 meter, or else you can consider this d as 0.45. Okay, now the problem is, okay, 0.45 means as per the discharge of 0.9 meter cube per second and a speed of 1.2 meters per second, your entire trapezoidal section depth is filled by water up to 0.45 meter. Okay, if you provide a depth of 0.45 meter as per the design what you had obtained now, this complete 0.45 meter depth is filled with water. But considering factor of safety, you should allow certain depth of trapezoidal section which is freeboard. That means free of water. Therefore, to this depth, as per the code book and as per the factor of safety, you add 0.15 meter extra depth. You have to add 0.15 meter extra depth. Therefore, what is the total depth of the trapezoidal section you have to provide? 0.45 plus 0.15, that is equal to 0.6 meter. Now you had know how much depth we have to provide for trapezoidal section for the given data. What is the second calculation you have to do? You have to find out what is the slope we have to provide. What is the bed slope we have to provide? That's the next calculation in the design. We will see how to calculate that. The design of longitudinal slope, it is calculated by using the formula, Manning's formula. Manning's formula is given by V is equal to 1 divided by N into R to the power of 2 by 3 to S to the power of 1 by 2. Okay, here V stands for speed of the water in the channel. We know that it is equal to 1.2. N stands for Manning coefficient. It is given in the problem as how much? 0.02. R stands for hydraulic mean radius. I will tell how to calculate that. And S stands for bed slope. That's what we have to find out. Here the thing is, we know V value, we know N value. Once you are ready with the R value, you can calculate S value. Now to find out R value, here is the formula. Hydraulic mean radius is given by the formula area divided by wetted perimeter. Area is how much? As we calculated in the first step, area is how much? 0.75 meter square. Now, what is this perimeter? We have to calculate wetted perimeter. Wetted perimeter means, see, as I said, this red line, what I had written, it is an extra board where water is not generally, it won't be there. Okay, we have to consider wetted perimeter means what is the length of this section, and from what is the length of this section, and what is the length of this section. Okay, we have to find out what is this length, what is this length, and what is this length. But the thing is, we know that bottom wetted perimeter is 1 meter plus. What is the thing? We should know what is the length of this side and this side. In order to calculate that, you already know the D value, correct? No, this is how much this depth. It is D. It is equal to 0.45. I repeat, here you should not consider this free board. If I take depth here, how much? 0.15 we had given extra board, so total depth will be 0.6. Therefore, we should not consider this free board because here we are considering only wetted perimeter. Wetted perimeter means the contact of water surface only you have to consider. Okay, anyhow, this depth is 0.45 as we calculated, and this horizontal distance here only you are written that as per the slope it is equal to 1.5 into D. Therefore, this is equal to 1.5 into 0.45. Okay, now as per the Pythagoras theorem, hypotenuse square is equal to sum of the square of the opposite two sides. Therefore, 1 plus 1 is the bottom width. So what I am going to do is, here I will multiply it by 2. You know why I am multiplying by 2? Because here also one side will come, correct? No? This side also I need to consider. In order to do that, what I am going to do? 2 into two sides I am going to consider square root of sum of the opposite side square. That will be equal to one side I am having how much? 0.45 square. 0.45 square. Another side will be how much? 1.5 into 0.45 square. If you do that, you are going to get what is the total wetted perimeter. This is directly, we know that 1. In order to calculate this hypotenuse distance, I am just using the Pythagoras theorem. Hypotenuse square is equal to sum of the square of the opposite two sides. Therefore, this side will be 0.45 and this side will be around 0.45 and this side will be 1.5 into 0.45. Since it is a square, I just took this to the square root. Therefore, this will be square root of 0.45 square plus 1.5 plus point for 1.5 into 0.45 whole square. I think I had shown the same in the next step. You can see perimeter is given by 0.45 square plus 1.5 into 0.45 square whole square root, because hypotenuse square is there. I took that square into this side. This will become square root. Whole multiplied 2 because two triangles are there. Plus 1 is the bottom width of the trapezoidal section. Whole together wetted perimeter is how much? 2.62 meter. Now, in order to calculate R, A is straight away available in the first step. P you had calculated in the previous step as how much? 2.62. So R value you are going to get it as how much? 0.286. After knowing this, just substitute all the values in this formula. V as 1.2, N as 0.02, R value as 0.286. Only unknown is S. Therefore, at the end we are going to get S value as how much? 1 in 332. Here you can see I substituted V as 1.2, N as 0.02, R as 0.286. S is the only unknown. After solving this equation, we are going to get S value as 1 in 332. That means you have to provide longitudinal slope for longitudinal drawing. How much? 1 in 322. And this completes design of longitudinal drawing. Thank you guys. We'll meet in the next session.